Right, so this is kind of a discussion that I wanted to have just to kind of frame from a RUM vendor and multiple RUM vendors and people using RUM, some of the hot topics or things that we think we would love to see in the future. A lot of that, through this working group and through the APIs that we design and such. I tried to solicit feedback from various other companies and individuals, both RUM vendors and other companies that are doing their own RUM. So I do have some feedback here from others. Obviously, this presentation is going to be from my point of view and will be biased towards the products that I work on. But hopefully there's other ideas represented here as well. And so I do want to thank SpeedCurve and Pinterest in particular for sharing a lot of feedback and helping build out some of these ideas. I have a bunch of high-level topics that I'm going to go through, kind of starting out with I was trying to think through what makes a good RUM API in particular, and like what APIs have worked really good for us and what other ones have been a challenge, and then kind of framing that discussion into specifics of things that we would love to see as an industry or as RUM providers or as people using RUM in the future. And just for clarification, RUM in this case stands for Real User Monitoring and is basically utilizing all of the performance APIs that we help build in this group. So the first thing to talk about is just what makes a good RUM API. And I had to kind of think back through all the APIs we've released over the years, the issues that we've had, the things that we want to change about them. And I came up with 3 top points, really. The first thing is that something that really helps in a RUM API is an API that can look backwards into history when possible. So notably here, something like the performance timeline or a performance observer with a buffered flag where even if your RUM collection library wasn't on the page at the time, as long as it loads at some point before unload, it can look back into history and understand what happened. As a third-party RUM vendor, we integrate with a lot of our customers' websites. Our customer build their websites in all sorts of various different ways, and even though we ask them to put our script as early possible in the page so that we can start gathering data as early as possible, that's not always possible. So sometimes we'll load directly from the head. Other times we'll load after the framework loads, after onload. Other times our JavaScript library, Boomerang.js, will load via a tag manager. And so we can't guarantee when we're going to be on the page. So being able to look back into history for important things is almost critical to what we can or can't do. And I have some examples of that later. Another kind of high-level API request when we build or think about APIs is attribution. And I think we've been getting a lot better with this lately. In fact, we were discussing one earlier with Fergal was talking about BF cache navigations, and he was saying, well, let's let people know why their BF cache didn't work. And that's exactly what we as a RUM vendor want, is if something good or bad is happening, or if we're measuring something in time, our customers really care about, okay, you've told me this number is changing, but why, and how can I fix it? And so being able to look at any supporting details, any debug information, any causes of these, why an event happened or why a time was, is really critical for providing value besides just measuring a number. And then the third key thing that I've been thinking about a lot lately, and we've been discussing this a bunch in the group, is SPA support. Designing these APIs with single page apps in mind really matters. A lot of our older APIs were designed even before single page apps existed, and we've had to think through and adopt them or add other things to make them work in the SPA world. Some of our current APIs don't work very well with SPAs. Like, for example, largest contentful paint, you can't reset that even if your customers are having in-page navigations. So thinking through these APIs when we're designing them would really help for RUM. Okay, so that's kind of setting the context for some of the other slides coming up. So first thing that I would love to see improved, and this may be more partial to the way that we ask our customers to integrate our product. So we have Boomerang JavaScript library is responsible for collecting data for Impulse. It's a 50 kilobyte or so, a little bit less than that library. We actually ask our customers to integrate us by using a loader snippet. So this is basically a bootloader. You can see it minified there on the right. It looks pretty large. It's actually 2.5 kilobytes. The reason we ask them to put all this junk in their every single page load is we, as a performance measurement company, we don't want to affect performance as much as possible, right? And while it may not be the best metric in the world to measure the onload event, static scripts or scripts inserted into the page can affect the load event. And we as a Boomerang, we as a RUM provider don't want to be affecting the onload event. The onload event still gives your visual indicators that something's ready, your progress bars. And so if we, for whatever reason, if our JavaScript library took a minute to load because our CDN was slow, we could actually be affecting the visual experience of our customers. So we actually jump through all these different hoops. Async and defer are not sufficient because they do block the onload event. This pile of text on the right uses either preload in modern browsers or iframes in older browsers to asynchronously and non-blocking load our main script. But again, it gets loaded in every single one of our customer pages, and it's basically just overhead. There is a possible solution in some thought that Yova's working on for resource loading orchestration, which I can kind of give some hints to the browser about how different things can load or what stage they can load at, or whether they have like a blocking attribute or not. And so I would love to see a little bit more work on that front to see if we can not have to send this text down, the script down every time. Okay, so the second, big thing here is attribution. As I was alluding to before, when RUM measures something, the first thing that matters when it changes is why, and the second thing that matters is, okay, how do I make it better, or how do I fix it? So some great examples lately. We have largest contentful paint. The event itself has the element attribute, which tells you what the largest thing that was painted. And you can collect that and you can bring that in with your data. And if you care, that can give you the best indicator towards what was causing these paints. Same thing for cumulative layout shift and the layout API, layout and stability API. The sources attribute tells you what caused the shifts themselves. And so these are just great examples of us thinking about how we can support our metrics with the debug information that we care about. Kind of on the flip side, we have layout tasks, or sorry, long tasks. Long tasks are awesome. They've enabled us to do a lot of things and really get insight into the browser about what's going on with the browser internals and the main thread, et cetera. But it doesn't have the right level of detail of attribution for what caused the long task. It has some very generic detail about whether it was the same or cross-origin frame or the self. And that can, kind of guide you towards what's causing your long tasks, but not really. At the end of the day, in your modern website, you have so many dependencies that it really doesn't pinpoint anything for you. And I know that we've considered, some sort of, main thread blocker for the long task or something. But really, if we could help improve long task attribution, I think it would help with a lot of things. I know that so Pinterest was really wanting to do better root cause attribution for all their field data. Again, for things like time to interact metrics or total blocking time or even first input delay, all of those are really affected by long tasks. And knowing what triggered them, knowing what the long task is about would really help with being able to improve them. There are some possible solutions here. The JavaScript self-profiling API we've been talking about could help. Unfortunately, you're probably not going to enable it for your entire web page, and so it's a sampling API, so you're not going to get it on every beacon. So I don't know if there would be a way to utilize part of that or something for long task attribution. Last year we had a great presentation from Patrick Hulse around Lighthouse's causal attribution model that I think actually would fit fairly well for getting some details into long tasks on why they're doing things. But it's definitely an area that I would love for us to improve and to think about for new APIs to make sure we have attribution. And then the third big area that I was talking about before is single page apps. So single page apps, they affect every single RUM metric. All of the metrics that we capture today either are irrelevant for single page apps, like the onload event isn't really as relevant if you have a single page app, or you can't use them very well if you have a single page app, like the largest contentful paint that we were talking about before. instrumenting, and so like all these different APIs, you have to like think about how they affect an SPA. We at Impulse, we basically have a top level Boolean flag for every property that's, is your site an SPA? And if so, we measure completely different things almost in some cases. And because an SPA is so different, knowing when, so we don't get like a load event for SPAs. We also don't get a starting event for SPAs in a consistent manner. And there's some potential solutions here with the App History API. But for soft navigations, those navigations that you have in the middle of your session in the page when the route changes, we can hook into some events that either the framework gives us, or we can hook into the history of API, or push state, pop state, hash change stuff to kind of know when a SPA starts. But knowing when that SPA transition stops is a big nebulous cloud. We with Boomerang jump through a bunch of hacks basically to listen to the mutation observer to know when things starts. We patch over XHR and fetch functions to know when things start, and then we try to figure out when network requests are idle. And it's a lot of work for something that I would love for the browser to help us with a little bit better. Yeah, and at the end of the day, like, a page view is different in reality from what the browser thinks it is, right? Like the page is loaded once the onload event fires, according to the browser, and then it's easy sailing from then on. Whereas in the real world, if you're building an SPA, like that load event didn't matter. Your framework stuff probably loads all your actual views and data after that. You have all these in-page navigations, and so it's a different world, right? With SPAs. And we're definitely getting better. Like I think we're talking about SPAs a lot more when we're designing things. But there are still some things that aren't really like SPA friendly. So examples here are like the largest contentful paint, right? It's a great metric. It's one of the core web vitals, but it doesn't apply to any in-page navigations. You're not resetting to a base level of 0 every time you in-page navigate. Whereas something like cumulative layout shift does work with SPAs because you have all the supporting data, all the supporting layout shifts, and you could reset your cumulativeness every time a in-page transition happens. And that's what we're doing and other people are doing to support SPAs with CLS. Yeah, and as we were saying before, like regular apps have very standard metrics from navigation timing, and SPAs don't. They either try to utilize some of the same metrics that a regular app does, like obviously DNS time and TCP time, all the connection time from navigation timing works for an SPA hard navigation, but the other events aren't as relevant. And so the ask here is to continue doing what we're doing and keep on focusing on making sure new APIs are supporting SPAs. But there's some examples here of, LCP has challenges with it. Excuse me. The next section is all about network request monitoring, which is something that we do and others do. The first part is visibility into the network, and I brought this up in the past a bit, and we don't have a good solution yet. We have some good proposals, but no good solution. Based on some research that we did, if you're measuring all the resource timing data on the page, you only have access to the data within your iframes within your main page and any same origin iframes. Any cross-origin iframe will be invisible to you. You won't be able to crack into it. You can't, use its APIs because there's the security boundary. And based on the crawl I did a couple of years ago, up to 30% of page content is in a cross-origin iframe, that resource timing that JavaScript doesn't have access to, which is over 50% of the bytes delivered on the page. For video, this is 97% of all videos in my crawl of I think it was like Alexa Top 1000 were in iframes. And as a RUM vendor trying to give visibility to our customers of what was happening on the network, presenting them a view of a waterfall that is incomplete is frustrating because it's like, well, here's most of your data, but not all of it. I can't tell you what I'm missing. There's just no indication either that you are missing anything, even about the scope of what you're missing. This is particularly painful for ads, right? I mean, a lot of ads are delivered in cross-origin frames. But even other things, other APIs that we care about, like the CLS, layout shifts happening in an iframe matter according to the CLS spec. Synthetic tools can measure the layout shifts happening in all frames, including cross-origin ones, but RUM can't. RUM can't break into that cross-frame barrier and get the layout shifts that are visually happening to the user. They're just invisible to JavaScript. So there are some solutions here. One of them is a thing called Bubbles, a term called Bubbles, which is basically a way for somebody doing a performance observer to request that anything happening in any child iframe gets automatically bubbled up to the top, which would just make the developer convenience of consuming this data a lot easier. Like today, we have to crawl all iframes to get all this data, and we do that every time we gather data, so it's overhead. And then there's a separate proposal for some sort of opt-in for iframes, cross-origin iframes, to opt in their data into this bubbling mechanism. So hopefully, in the future, we could have ad agencies opt in to sharing their data about their performance and being able to bubble up to the top level frame, and we'd actually be able to report on the total page weight, not a portion of your page weight, and we don't know what portion that is. The second part of network monitoring that we care about is just observing when network requests start. This is important for a lot of different things. Pinterest was mentioning around measuring network congestion or idle time. For Boomerang, for Impulse, we do our SPA monitoring by monitoring the network. And as I mentioned before, we hook into Mutation Observer and Patch, Fetch, and XHR to be able to get some sort of indicator when a network request is starting and thus ongoing. But otherwise, it's not complete. We don't know everything that's happening on the network, and it makes some of these calculations very impossible to do, to really know what the idleness of the network is. So some sort of fetch observer or network observer, we've talked about it a bunch in the past. It would really help for some of these monitoring scenarios. And then there is some ongoing work for fetch and service worker integration, and Pinterest had a strong desire here to get cache hit rates from their service worker in addition to their overall browser cache hit rates. So movement on that would be super cool. And then the last thing was for resources in general, there is a set of information that is not exposed in resource timing today that could enable some cool scenarios for things that we could give to our customers and help them make their sites better. So the request.destination or the dependency tree of all the resources on the page, like basically what caused what to download, could lead to a lot of optimizations that either a site could use or a RUM provider or a CDN could do around knowing when things should load when, and like what's the critical path for loading different content. So it'd be interesting to pursue that a bit. Content type and response code, not available in resource timing today, could really help with a bunch of different optimization and A/B testing scenarios and error reporting if things are not working well. I know that for response code, you have things like the reporting API to report on problems, but getting that information in resource timing itself would be very helpful. One other thing is we haven't had consistency with reporting of resources that are not 200 level. It's actually getting better, and there's been a bunch of bug fixes around this lately, but some browsers don't report 400, 500 level responses, or don't report things if there was a DNS error. And it's just an overall visibility thing. Like I would love for us to get most of the information that you can get from the DevTools waterfall in resource timing, because there's always questions on why are they different. And then we have a discussion in the past about TAO, timing allow origin, and its relationship with the cores and what information gets exposed where. And I think it would just be worthwhile to continue that discussion and figure out how we can get some of this more detailed information if we think we can. So some of the issues tracking that are at the bottom. Last thing is reporting API. So, RUM vendors and others are looking into this. We've had some challenges with browser extensions polluting data in reporting, both from CSP reports and other things. Not sure if we could figure out a way of tagging the source if it's a browser extension or not. We would love to be able to tag on additional data for the reporting API in some way, metadata. Today, the only way that you really communicate data is through the URL that you report to. So you specify your endpoint URL, but throughout a page's lifetime, there's some additional metadata that might be useful, like the user's session ID or their session length or other information that changes over time. And it'd be nice to say, hey, reporting API, when you deliver a thing, here's the latest information I want you to also include in the body payload. Not entirely sure about the privacy and security aspects of that, but Ian, at some point I would love to chat with you about any ideas you have around that. And then the final thing is there was this presentation last year around possibly using the reporting API as a more reliable beaconing mechanism. And I think it's actually already come up a little bit earlier from a discussion. We've done some research. We at Impulse sent our beacon, our RUM beacon, at the onload event. Sorry, the load event. I'll call it load event to distinguish it from the unload event. We send our beacon when the page loads because it's the most reliable point to send data. We would like to be able to send the beacon later because obviously things happen beyond the page load event. JavaScript errors, other important things, CLS, a large contentful paint, those events can all happen after the page load event. And you could also send a separate unload beacon if you would like. There's potentially downsides to sending two beacons. Some of our customers delay their beacon till later, but the longer you delay, we found the less likely you're going to get that data. So as an example, on some research that we did, if we send a beacon, even with no payload, at the page load event, about 90 to 93% of those beacons arrive. If we wait to send them at the unload, and this is with hooking for unload, well, I don't even know if it's necessarily unload, page hide visibility change before unload. That's what I mean by unload here. Only 82% of those beacons arrive. And so there's obviously essentially a 10% discrepancy in real terms of beacons arriving or not based on when you're sending your data. And that may not be acceptable to some of our customers. They may not want to lose that visibility. You don't know if that's good experiences or bad experiences that you're not seeing. It's just lost beacons, lost experiences that aren't going to get reported. And that's including using the beacon API and like all your best practices, right? I have some research on that if anybody wants to dig in more, but some of our customers that may be okay because they want to make that trade-off of recording more data but on less beacons, if that makes sense. Others may not. So anyway, we talked last year about a reporting API for RUM and maybe having a way of queuing up data to be sent and then having the browser be that deliverable, the reliable delivery mechanism for sending it at the end of the day. Kind of like a beacon API plus or whatever you want to call it. So that would be helpful. Okay, I spoke a lot. I just want to say thanks to SpeedCurve and Pinterest for some of their ideas I incorporated into this, and definitely want to chat with anybody else that has ideas. But that's the presentation. I realize we only have a few minutes, if you will, for if there's any discussion to be had. Otherwise, we can always take it off.